Alright, so I will do the previous semester question, some on theories and also on the calculation. So you need to know both. Okay, so let's start with this one, January 2020. Discuss the 3 advantage and disadvantage. For theory, we always ask you what are the advantage, disadvantage, and then we ask you on the benefit, and can ask you on the factor. So read the question. 3 advantage and 3 disadvantage. So 3. On what? On the product type layout. We have the retail. Retail ni termasuklah shopping, okay, shopping complex, and then also all the supermarket, how they arrange their product. And then we have office layout. Okay, dua ni on service, and then on the facilities or on the manufacturing kita ada 4, in which we have the process layout, product layout, cell layout, and also fixed position layout. Fixed position is for the bulky thing. So for example, ship, you are building a ship, so it's a fixed position. And then process is by process, from one process to another process. And also cell layout is for on the cell punya design, and last kali is product type of layout, usually assembly line panjang. Okay, so for this one they ask you for the product type of layout. So it's kita ada 4 yang mostly for the manufacturing, so focusing on product. So what is the advantage? Product kita tahu the high volume, very high, laju. Contohnya juice bottle, okay, soft drink, screw, nuts and bolts, apalagi pencil and so on. All of that is a high volume. The volume keluar banyak. And because of the high volume, the cost going to be low. Okay, and then that's 2 points kat situ low cost per unit and also high volume. And then we can specialize the equipment. So it means that kita boleh arrange the equipment. And then the best one is dia boleh buat automation. Okay, compared to process kita tak boleh automation. So but for product layout, yes, you can automation, in which you can introduce robot, you can introduce conveyor belt, you can introduce apa lagi, sensor and so on, because they have the layout yang mudah disusun. It go by sequence. Okay, that's the advantage. So the disadvantage is that dia tak boleh flexible. It means that kalau dia buat jus 1 liter, dia jalan ke 1 liter dulu. Dia tak boleh nak kejap 1 liter, kejap lagi nak jadi 500 ml, tak boleh, because they have sequence. So if they want to change the bottle, so they make sure that the whole line akan use the same thing. So that's the disadvantage. Dia tak flexible macam process. And satu lagi, dia punya disadvantage is that whenever one of the machine on the line break down, the whole line will be stopped. Okay, contohnya you want to bottle the juice. So dah filling and then nak label, and then bila you nak cap, machine nak letak cap tu dia sangkut, dia rosak. So what happened? Can you skip the process? Tak boleh sebab dia dalam straight line. So not very robust. Maksud dia tak boleh ada breakdown. It going to cause the whole line to stop. Okay, so disruption memang not friendly kepada product type of layout. Okay, and then last kali, work can be very repetitive, so that if you work in the line as a person, you do the same thing, put the cap on the bottle for 10 years, you will get bored, and also you akan make mistakes sebab you dah terlalu, you dah jadi robot dah. You doing it repetitively, so it will maybe lead to error and so on. Okay, so dia akan jadi bosan. So that's the product. Kalau soalan tanya, okay, about the process, advantage and disadvantage, so I think you have no problem to give all the detail. Okay, next, June 2019, okay, discuss the modern warehouse. Okay, they mentioned about ASRS and also cross-docking. What is cross-docking? So you need to watch the YouTube so you know what is cross-docking all about. ASRS, bagi definition dulu, is a automated storage and retrieval system. It means that all the inventory dekat dalam warehouse tu, you masuk je barcode ataupun you scan je dia punya all the information, dia akan carikan untuk you. They know where is the exact location of the item. You tak payah pergi on the racking and look for it, because ni kalau kita tengok ASRS ni macam ni rupa dia. It's like a high forklift in which dia ada fork untuk go and even they can go up to, nampak ni boleh sampai I think more than 12 story dia boleh go tinggi so high. So dia akan cari kat mana that item in less than few minutes. So kalau kita guna human, it's going to take lots of time nak cari forklift and then nak kena cari location. But by using ASRS, it help to improve the productivity 500%. Can you imagine that 500% kalau guna dia? Okay, so imagine if you have a very big warehouse, so you need to have the ASRS, not a manual system. A variety of computer control system for automatically placing and retrieving. Okay, loads from defined storage location. So they are using barcode, RFID to do the storage and retrieval. Okay, so these are some of the example of the technology in the warehouse system. Okay, then dia kata what about the cross-docking? Okay, cross-docking is barang tu dia tak duduk lama pun dekat warehouse. Actually cross-docking ni dia sesuai untuk all the logistik yang macam JNT, pos laju and so on, in which let's say barang daripada utara, Kedah, Perlis, Pulau Pinang, what they do, dia akan jumpa di KL or Selangor before dia pergi ke Johor, ke selatan, because dia akan merugikan if you bring, let's say, okay, ada parcel daripada Perlis, Kedah nak pergi Johor, lori tak penuh, so takkan dia nak go all the way to Johor and nak patah balik. So they have a cross-docking bay, kita panggil, and kat situ dia penukaran barang berlaku. Okay, tapi sebelum penukaran barang tu berlaku, they need a very good scheduling. Sebab lori tak nak tunggu lama-lama. Lori sampai dengan lori yang ambil, dia memang have a very good timing. So that's sebab ada lori lain tengah beratur nak masuk. So the cross-docking punya concept is material are moved directly from receiving to shipping, and tak ada pun dia duduk lama dalam warehouse. Paling lama pun one day. Sebab dia tak ada racking system. Dia tak ada macam ASRS. So kalau ada delay, what happen? The warehouse going to be haywire. So diorang tak nak ada delay. So make sure lori datang dan lori menunggu on time and pick up 1 hour and dia boleh jalan. Okay, so dia maximiskan all the lori yang nak outbound with all the parcel so that they can reach. Dia boleh singgah lah Melaka ke Seremban ke Johor ke, on the way dia turun. Okay, so dia must have a tight scheduling and kena ada accurate shipment information. So mesti guna barcode or RFID. Tak boleh manual. Okay, lori sampai berapa ada 20. Okay tak boleh manual. So janganlah berani buat cross docking if you don't have a good system. Sebab you need the identification, sebab you don't want to make mistake when you're doing the cross docking. So kalau we look here, so mostly the inbound coming and then the outbound lorry dah standby. Okay, so barang transfer pakai forklift or sometimes they use conveyor straight to the next lorry. Okay, that's we call cross docking. Alright, 5 marks on that. Okay, this is another one on theory. Describe 5 layout design consideration. Contohnya nak raya, so you nak, mak kata okay jom semua orang tolong kita nak ubah furniture. Kita kena consider apa? Kita kena consider make sure tak ada sofa letak betul-betul depan TV, cover the TV. Okay, kita tak nak letak sofa dekat dengan makan, terlalu dekat sampai orang nak gerak tak boleh. So kita make sure laluan untuk masuk keluar clear, tak ada halangan. So all of that kita consider. Kena consider juga colour, matching tak sofa ni dengan dinding. Sometimes pun kita consider. So all of that is under consideration, not just suka-suka je. So you must have a reason why you nak buat macam tu. Okay, so describe 5 layout design. Let's say you nak masuk a new factory ataupun you nak besarkan you punya factory. Apa you kena consider untuk dapat a very good and efficient layout is kena consider capacity and space requirement. Jangan main beli mesin sekali tengok pintu kilang tu kecil je, tak muat. Apa yang nak kena buat lepas tu? Takkan nak kena pecahkan dinding. Dah tak ada choice. Kita tak buat betul-betul consideration, tak ukur, okay, tak check dia punya power outlet. Let's say kita kena upgrade pula using different voltage and so on. So you need to see this capacity and space requirement. Is it enough or not? Or takut nanti you have to add more apa orang kata cost because of this problem. So we don't want to create more problem. Cukuplah untuk kita have a very good layout. So capacity and space requirement is very important, especially allowance for the machine. Tak mahu machine terlalu rapat. Okay, because maintenance nak masuk susah. So you need to consider that. Ada 10 oven letak, oven dekat-dekat. When breakdown or something happen, dekat plug ke, dekat mana nak buka belakang dia tak boleh sebab there are no space for the maintenance crew to get in. Okay. And then selection of material handling equipment. Kita dah buka kilang cantik sekali bila dah susun, bila tanya daripada warehouse ataupun daripada store nak pergi line, kita nak transfer pakai apa? Oh, kita dah beli 3 forklift. Sekali bila tengok forklift tu tak muat. Dia buat one way je, tak ada patah balik. Lepas tu fork dia yang dia bawa tu boleh langgar all the machine. So kita tak consider tu. So make sure before you decide what kind of material handling, you can make sure you have enough space. Conveyor belt, you must have enough space. Nak letak robot, you must have the enough height supaya robot tu boleh move freely. Okay. Environment and aesthetic. Environment is very important, especially lighting, temperature, ventilation is very important. We put everything crammed in the factory and the ventilation is not good. The factory panas and then all the employees will suffer because of the heat, tak boleh release. So all of this kita kena consider when we want to do the layout. Make sure ventilation have enough circulation, and then the lighting is enough, okay? And then also the agronomics of the people that work. So tak adalah dia kena tunduk or dia kena berdiri all the time. So all of this you need to consider. And flow of information is very important. Dekat layout tu, mana pintu masuk, where is your entrance and where is your exit is very important. Entrance and exit kalau boleh jangan share because it's going to be difficult. So especially we have a big factory, make sure ada one way in and out. Jangan bagi lori tu patah balik sebab it can cause hazard, accident and so on. So in and out have a different way. Tak boleh kita sekalikan. Itulah orang hantar barang, lepas tu nak ship out pun the same entrance, tak boleh. So they have to get a separate one. So that the flow nicely done. Okay, so daripada pintu depan, the process A, B, C, D and then terus keluar kepada shipping and keluar terus ke customer. So that's the best. And cost of moving very important. Kadang-kadang dapat kilang very big kilang, dapat besar sangat, 2 padang bola. And then bila letak mesin satu sini, satu ujung sana. You lupa, forklift tu kita nak kena letak gas, kita nak kena ada cost. So asyik ulang aja, so kita dah rugi kat situ. So make sure you calculate the cost of moving. Okay, let's say kalau tolak troli guna orang, 10 orang tu dah penat sebab jauh sangat. So benda tu kita kena consider, okay, before finalize the layout. And very important, safety. Yes, safety. Okay, make sure tak ada tripping hazard, wiring tak bersepah, and machine tak ada attachment yang boleh orang terhantuk, sangkut, and so on. So all of this you need to make sure you consider this when you do the layout. Okay. So I think that's on the theory part. Okay, so theory again, you're gonna tahu what the advantage and disadvantage of the type of layout, and then you're gonna tahu what the consideration when you design a new layout, and also apa tadi? You gonna tahu about cross docking or SRS. Okay, they have lots of theory that they can ask you. Okay, these are the calculation part. January 2020. Okay, calculation part usually apa dia akan tanya? First sekali, you kena tahu the definition. Siapa yang tak ingat, ingat balik. Apa cycle time? Cycle time adalah masa, time untuk membuat satu produk, satu item. Kalau ada jual kipas, satu kipas berapa lama nak buat. Kalau jual kerusi, satu kerusi tu berapa lama nak buat. That's mean by the cycle time. From the start, the proses-proses sampai barang tu siap, kita panggil cycle time. 10 minit, 20 minit, 5 minit. 20 saat pun ada, depends on the item. So cycle time is masa untuk membuat satu item. Okay. Next, you kena tahu output. Output bukan masa. Selalu orang salah anggap output tu masa. No, output is how many you buat per day, per week, per month, per year. Berapa banyak benda you buat. Let's say kereta. 20 cars per week. Okay, kalau dia buat fan, okay, 10 fan per day. So dia per day per week tu adalah output pengeluaran. Okay, so don't confuse output dengan cycle time. Okay, then you need, okay, kita baca soalan ni, apa information dia bagi? First kali kita kena tengok kat sini ada task. And then kita tengok time dia dalam second or minute. Kalau dah make sure bila task time tu dalam minit, cycle time you mesti dalam minit. Jangan have a separate orang kata unit untuk time. Check task time. Task time minute, cycle time must be minute. Okay. And then construct a precedent diagram. Okay, bubble and arrow if you remember that. Calculate cycle time. Cycle time always kena cari dulu apa-apa hal pun. Okay. Determine the number of workstation. Assign the task into workstation and evaluate the line efficiency. So information diberi adalah hourly output 33.33 unit. Apa maksud dia? Output. Okay, maksud dia dalam 1 jam, kita tengok terus dia 60 minit terus kita nak convert 60 minit. Dalam 60 minit, dia buat 33.33. Jangan tanya Umi kenapa ada 3.33 kat belakang tu. Itu information dia bagi. Okay. 33.33 apa ni? Electric device. Dia tak cakap apa, so we assume unit. Unit lah dia kata. Okay. So kita ada information ni. Daripada information ni, boleh tak kita cari 1 unit berapa minit? Boleh, sebab kita dah ada information 1 jam 33.33 unit. Okay. Kita dah lega kat situ. Okay. And then kita boleh start do the question. First kali dia kata construct precedent diagram. Precedent diagram adalah bubble and arrow. Check the task, kita ada sampai H. And then tengok dia punya arrow menghadap mana. So kita baca kalau tak kisahlah dia bagi kat sini precedent ke, sebelum ke, selepas ke, janji kita tahu susunan dia adalah A, B, C, D, E. Okay, that's the flow. So kalau kat sini cara mudah nak baca, kita tengok tepi ni, sebelum A tak ada apa. So A pergi B, B pergi C, B juga pergi D, and B juga pergi E. Okay, done. Now C pergi F, and then D and E pergi G, and F and G pergi H. Okay, habis. Okay. Next, put the task time for each task. Okay, when you get this one, now you boleh start kira cycle time. Nak kira cycle time, kita ada info tadi, 60 minutes ada 3.33. So 1 unit is 60 divided by 33.33, so 1.8 minute. So nak buat satu item tu 1.8 minute. Okay, now kita dah ada cycle time, then dia kata determine the number of workstation. So we can use this formula, and sum of all tasks, this one, sum of all tasks, 6 minit, divide by CT, CT is 1.8. So kita akan dapat 3.33. Remember, N is a whole number. You have to round up. Walaupun you get 3.1, you have to go 4. Okay. So for this case, 3.33, so you need to have 4 workstation. So all these tasks will be going to be grouped into 4 workstation. Okay, now dia kata assign the tasks. So we have to make sure all the tasks duduk dalam workstation masing-masing. So remember this table, okay? Workstation 1, every time start with new cycle time, 1.8. So always start with A. Sebab apa? Tak ada option. Selagi A tak gerak, B tak boleh gerak. So we choose A, 1.4. Task time, and then 1.8 minus 1.4, we get 0.4. Ada tak ada bagi syarat apa-apa? Use greatest proportional weight, tak ada. Most following task, tak ada. So kita guna kaedah jangan membazir. Okay, kaedah jangan bazir is the most easiest one. Sebab dia tak cakap syarat apa-apa. So kita dah ada 0.4, boleh tak masuk 0.5? Tak boleh. Boleh tak kita langkah? Lagi tak boleh. Tak boleh melangkah. So next should be B, but B 0.5, tak muat, baki aja 0.4. So you tutup, bawa ke idle sebab ini adalah kelebihan, and you pagarkan A. So workstation 1 A saja. Then baru you start with B. So buka workstation 2, letak cycle time baru 1.8. Start with B 0.5, 1.8 minus 0.5, you get 1.3. Okay, now 1.3, you can choose C, D, E. Okay, the best thing is to congak dulu. Okay, jangan pilih, nak pilih E lah, E besar. Tak, kadang-kadang, you kena congak dulu, cukup tak? So, now you ada 5. You dah pakai. So, ada baki 1.3. So, kita tak nak bazir. Kalau kita ambil E, kita akan ada berlaku pembaziran kat situ. So, kalau kita tahu C dengan D dicampur, cukup-cukup dapat 0.7. Cukup-cukup boleh dapat 1.3 kan? Kita congak, okay. So, better kita pilih C dan D. So, we choose C, 0.6. So, 1.3 minus 0.6, kita dapat 0.7. And then kita masukkan D. So, D 0.7. So, okay, just nice. We don't have any extra. So, tutup. And kita pagarkan B, C, D. Okay. Now, kita buka workstation number 3 with 1.8 cycle time baru. And then kali ni kita boleh pilih E and F. Tapi kita congak dulu. Kita tengok kalau kita ambil E dengan F, macam E dengan F boleh lah dapat 1.3. Okay. And kalau kita ambil ini dengan ini pun actually boleh dapat 1.8. So actually jawapan dia boleh ada a few combination as long as you tidak exceed the cycle time. Okay. So untuk ni Umi nak ambil E and G lah. Okay, E and G. So dapat 1.8. Sebab ngam-ngam je cukup je kan. So kita tutup. So sekarang kita tutup sini. So kita tahu tadi kita kira ada 4 workstation. So kita boleh senyum. Cukup. Kita ada kat sini untuk masukkan dalam workstation terakhir. So start with 4. 1.8 cycle time baru. And then kita ambil F dulu baru H. F 0.5 and H 0.5. So ada baki 0.8. Okay, Umi, kalau saya ambil E dengan F boleh? Boleh. Kita dapat 1.3. And then kita ada baki sikit. Lepas tu yang ni pun kita ada baki. Kalau you all tengok, you all punya N akan dapat 1.2 juga. Walaupun you have different combination. Ideal time dia akan sama. Okay, katalah you ambil E dengan F, G dengan H. Dia akan dapat 1.2 juga. Alright, so don't worry. Ada few combination. And so kita penuhkan syarat betul 4 workstation and tutup semua and dengan berbaki 1.2 minit. Okay. Now soalan seterusnya, evaluate the efficiency line. So formula efficiency adalah all tasks, sum of all tasks divide by CT darab N and then time with 100. So kita ada sum tadi, all tasks 6 minit. CT 1.8 times 4, workstation kat sini 4, kita dapat 83.3. Okay, dah habis. Sebab kita dah menjawab ke semua 4 soalan. Okay, so you get 10 points for that. Okay, so now we're going to the June 2018. Okay, 2018. First kali Umi kata check apa info dia bagi. Okay, kita sekarang apa-apa kita perlu cycle time tu sangat penting. Ada tak info untuk cari cycle time? Kita scan dulu. Kat sini dia bagi time of work available per day. Okay, ni lain sikit pada tadi. So, satu hari dia ada 400 working time. Maksud dia, waktu bekerja dia 400 minit. Okay, check dulu dalam minit. Okay, perlu tak convert? Tak perlu sebab dalam minit dah. Okay, set. And demand for a fan. Okay, ni kilang buat kipas 100 per day. So, ada satu lagi information. Within one day, dia buat 100. Nampak macam boleh cari cycle time kat sini. Okay, mari kita check cycle time. So, kalau sehari dia kerja 400, boleh buat 100 unit. So, 1 unit kipas dibuat dalam masa 4 minit. Cuma 4 minit, pas siap. So, 4 minit diperlukan untuk buat satu kipas. Okay. Right. So, clear macam check cycle time. Now, kita boleh start lah buat precedent diagram. Yang ni suruh kira apa? Efficiency. Dia suruh kira theoretical dulu. Okay. And then, dia suruh determine total idle time kalau B dengan D pula berubah. Oh, dia ada buat perubahan. Tak apa, kita kira 1, 2, 3 dulu. Okay, 1, 2, 3 dulu and then last kali kita bawa 4. So, lukis dulu precedent diagram. So, kat sini ada F. Okay, sum dulu sebab nak pakai nanti. CT tadi kita dah kira 4. So, adalah bubble sampai F. Okay, now kita nak start buat dia punya arrow. Sebelum A, none. And then daripada A pergi B, A pergi C, A pergi D. Wah, banyak And BC pergi F. And then DE pergi ke F. Okay, habis. Right? Ada tak dia bagi syarat apa-apa tadi? Most positional weight ke apa ke? Tak ada So kita guna syarat kita, jangan membazir. Cakap. Okay, calculate efficiency. So awal-awal dia dah kira efficiency kan? So kita letak dulu dia punya task time. And then nak cari efficiency kena ada N. So kita buat N dulu. Kita assignkan dulu. Okay. So kita assignkan dulu. First kali kita buat workstation pertama. So workstation pertama cycle time dia 4. Kan cycle time 4. So buka 4. So kita tahu yang ni 2. And then kita boleh pilih ni 2. Jangan bazir. So kita akan pilih A dengan D. So 4. Okay, nice. Tak ada pembaziran. Buka workstation kedua. Start dengan 4. So kali ni kita congak lagi. Kita nampak okay 2 ni boleh combine. So kita akan start dengan B dengan C. 4 tolak 3 ada lebih 1. Letak C 1. So 1 nice. So kita pagarkan dia. So kita nampak wah ini pun nice. Okay. Wah soalan ni very good lah. Sebab mudah kita nak tengok kan. So kita tahu ada 3 lah workstation dia. So the workstation ketiga start dengan 4 lagi sekali. Cycle time baru. E dulu. And then baru F. And then tak ada juga. So idle time dia 0. Okay. Kalau idle time 0 ni maksud dia apa? Efficiency dia akan jadi 100%. 12 bahagi 4 workstation. 4 tadi apa cycle time. 3 workstation kat sini. 1, 2, 3. So kita darab 100 dapat 100%. In the real life, hardly to get 100%. Itu terlalu perfect. So this one is maybe on paper kot. Dia very, ataupun proses dia very simple. You can get 100%. So we done with the efficiency. So sekarang kita nak jawab soalan nombor 3. Now dia kata theoretical. Bila theoretical, kita akan guna formula ni. Okay, kalau tak ada word theoretical tu maksudnya you kena buat manually. So bila dia kata theoretical, so you guna sum of all tasks, iaitu 6 tadi, 12 sorry, divide by CT. CT dia tadi berapa? Kita dapat 4. So 3 workstation. So betul lah tadi, confirm kan? Okay, so kita dapat 3 workstation. And now kita buat soalan yang bila ada changes. Okay, now dia kata, apakah jumlah baru idle time kalau B dengan D dipendekkan? So sekarang B daripada 3 jadi 1, D daripada 2 jadi 1. So bila kita lukis balik, B ni jadi 1, D jadi 1. Now kita kena susun balik. Okay. So bila kita tengok dalam ni, workstation 1, cycle time tak berubah dia kata. Cycle time sama. So kita nampak 1, 2, kita boleh masukkan 3, 4. Okay. You boleh pilih A, B, C boleh. A, C, D pun boleh. There are a few combination, don't worry. So for this one, I choose A, D, C. Okay, A, D, C. Ada balance tak? Tak ada. Sebab 1, 2, 3, 4. Nice. And then untuk ni pula, okay. Alamak, ingatkan boleh tutup dengan 2. Tak boleh sebab 1 campur 1, 2 campur ni 5. So nak tak nak kita kena gabungkan B dengan E saja. F tak boleh masuk. Okay, so kita buat 1. Nak tak nak kita terpaksalah buka juga workstation ketiga untuk F iaitu 3, 4 tolak 3, 1. So kita ada balance kat sini. Kat sini pun kita ada balance sebab 1 campur 1, 2. Cycle time 4, so kita ada 2. So sekarang ada tak idle time? Ada. Idle time ni berapa? 3. Yang ni yang dia nak ni. So determine the total idle time if B dan D berubah. Jawapan dia adalah 3 minit. Okay. So kita dah jawab soalan 1, 2, 3, 4. So kena tulis kat sini. Sum ni 3 minit. So kita tahu ini jawapan dia. So kita bagi markah kat sini. Berapa markah? 2 markah. Okay. Ini berapa markah? Yang ni pun 2 markah. So total selalu 10. Okay. I think that's all. Kita dah jawab.